What is a logarithm? We have all seen equations like this before. These are called exponential functions. In many cases, it is simple to find x. We know that 2 cubed is 8, so x must be 3. But what if the numbers do not work out so neatly? Here, x cannot be 3, because that gives 8, and it cannot be 4 because that gives 16. So the solution must lie somewhere between 3 and 4. This is exactly where logarithms come in. A logarithm is simply the inverse of an exponential function. Let us look at the standard exponential curve. Y equals 2 to the power of x. If you input x equals 3, the function outputs y equals 8. But what if we already know the output, and we want to find the input? In this case, we need the inverse function. Geometrically, an inverse function is just a reflection in the line y equals x. This swaps over every x and y coordinate pair, so the inverse of y equals 2 to the power of x is y equals log base 2 of x. This new function allows us to take the output of an exponential function and use it to recover the input. So if we want to solve 2 to the power of x equals 10, we set y equal to 10 and then use the inverse function. X equals log base 2 of 10. This gives a decimal of 3.3219 to 4 decimal places. So that is all a logarithm really is, the inverse of an exponential function. Its whole purpose is to let us find the input of an exponential function when all we know is the output. Now let us take a look at a couple of practical examples to recap. Example 1. Using the definition of logarithms, we write x equals log base 12 of 20,736. If you put this into your calculator, you will find x equals 4. Example 2. Solve 324 to the power of x equals 18. Again, take the inverse. X equals log base 324 of 18. This actually works out to 1/2. In other words, 18 is the square root of 324. And in the next video, we will look at how to actually enter logarithms on a calculator, especially when we need to change the base to something our calculator supports, like base 10 or the natural logarithm.